Hello, participants. Dinesh Kumar. Dinesh Kumar, is it audible? Dinesh?
Sir, it is audible.
Okay, fine. So I'll be sharing the screen. So today, we'll be starting module 2. So module 2 is the process management. Let other participants join. Exactly at 9:45, we'll be starting. Okay. Is it audible?
Sir,
Fine. So exactly at 9:45, we'll be starting. Yet the participants needs to enter. Only 4 are participating now. So in the previous slides, we were dealing with the OS, introduction to the operating system and the goals of operating system, and we are done with the module 1, along with the important questions and the small hints for each and every question. So from examination point of view, so what are all the list of questions that might appear in module 1? So those were discussed in the previous class. And today's class will be starting with the module 2. So module 2 is the process management. Already it's time, but only 6 have logged in. Abhishek N, are you there?
Yes, sir.
Abhishek N, Dinesh Kumar,
yes, sir.
Sushma H, are you there?
Yes, sir.
Yeah. So please listen to the explanation. So I do agree that we have some network problem. So we have so many reasons, right? So but still you need to attend the examination. Alva, exam barilebekalva. So for that reason, you need to say, give some concentration on the explanation. Okay. Already it's too late. Only 12 members have logged in. So, but I can't wait for all the members to enter. So let me start. Okay. Are you with me? Hello?
Yes, sir.
Yeah.
Yes, sir.
So let me start the module 2. So module 2 is the process management. So this process management is one of the second main function of the OS. So the first function was resource management. So then process management and memory management, we have security and protection. So among those operations of operating system, so now we are dealing with the module 2. So module 2 is process management. Okay. So before you go for the actual concepts involved in module 2, you need to understand some basic definitions and some basic concepts. So without which it might be difficult for you to understand the upcoming concepts. So for that reason, so let me have the details of this second module. So second module is process management. So here we have the overview of the processes inside the operating system, and we have something called as PCB. PCB stands for process control block. Okay, PCB stands for process control block. So we have fundamental state transitions of a process. So any process will be having so many states, right? A process can be staying in say around 6 or 7 state, that will be dealing with. And we have something called as threads. Okay, so we have threads and basically we have two kinds of threads. So one is kernel level threads and the user level threads, and next will be non-preemptive scheduling. So once I say scheduling means we'll be having two types of scheduling. So one is non-preemptive and the second one is preemptive kind of scheduling. And examples for non-preemptive scheduling is FCFS. FCFS stands for first come first serve, and SRM stands for shortest request next. Okay, I repeat, FCFS stands for first come, first serve, and SRN stands for shortest request next. And we have something called as preemptive scheduling. An example for the preemptive schedulings are RR for round robin, and we have LCM kind of a scheduling. So next we have scheduling in Unix and scheduling in Linux. Okay, so like these are the contents of process management. So let me start with the module 2. So the name of it is process management. Let me understand the word process. So this process is defined as the executable form of a program. Okay, so we have a definition for process. So where I can define the process as executable form of a program using some set of resources. So why this using some set of resources is being used? Because any process will be able to use the resources if and only if it is in the main memory. Okay, so if any process is not been placed in the main memory, so but still it is in the hard disk, so then that can be called as a program, where program is nothing but a set of instructions given to any computer, any system, any processor, so as to do some particular task, right? So what I mean to say is, suppose if you say write a C program, or say like any high level program or assembly level program. Okay, suppose if you write any piece of code, okay, that piece of code will be stored in the hard disk initially. Okay, so suppose if your program or the code what you've written is stored in the hard disk, means that particular program will not be in need of any resources as such. Why the program doesn't need any resources if it is stored in the hard disk? ಅಂದ್ರೆ ಯಾವುದೇ ಒಂದು ಪ್ರೋಗ್ರಾಮು ನೀವು ಬರೆದ ಮೇಲೆ ಅದನ್ನ ಸೇವ್ ಮಾಡ್ತೀರಲ್ಲ, that particular program will be saved in the hard disk. And while the program is in the hard disk, that particular program will not be in need of any resources as such. Why? Because it is not yet been selected for execution. ಆದ್ದರಿಂದ ನಿಮ್ಮ ಪ್ರೋಗ್ರಾಮಿಗೆ ಯಾವುದೇ ರೀತಿಯಾದ ರಿಸೋರ್ಸ್ ಅವಶ್ಯಕತೆ ಇರೋದಿಲ್ಲ. So next point is, suppose if you want to execute that particular program, means what I should do is I should be able to bring the program from hard disk to the main memory. So once your program stored in the hard disk is brought to the main memory, so then we call it as process, right? Hence I'm saying that process is the executable form of a program using some set of resources. So this means that if and only if your program is stored in the main memory or in the RAM, then only CPU can access it. ಅಂದ್ರೆ ನಮ್ಮ CPU ನಮ್ಮ ಪ್ರೋಗ್ರಾಮ್ಸ್ ನ ಎಕ್ಸಿಕ್ಯೂಟ್ ಯಾವಾಗ ಮಾಡ್ಲಿಕ್ಕೆ ಸಾಧ್ಯ ಆಗುತ್ತೆ ಅಂದ್ರೆ, ಇಫ್ ದಟ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಪ್ರೋಗ್ರಾಮ್ ಈಸ್ ಬೀನ್ ಪ್ಲೇಸ್ ಇನ್ ದ ರ್ಯಾಮ್, ಅಂದ್ರೆ ಮೇನ್ ಮೆಮೊರಿ ಅಥವಾ ರ್ಯಾಮ್ ಅಲ್ಲಿ ರ್ಯಾಂಡಮ್ ಆಕ್ಸೆಸ್ ಮೆಮೊರಿಯಲ್ಲಿ ನಿಮ್ಮ ಪ್ರೋಗ್ರಾಮು ಸ್ಟೋರ್ಡ್ ಇದ್ರೆ ಮಾತ್ರ ನಮ್ಮ CPU ಆ ಪ್ರೋಗ್ರಾಮ್ನ ಆಕ್ಸೆಸ್ ಮಾಡ್ಲಿಕ್ಕೆ ಸಾಧ್ಯ. ಅದೇ ರೀತಿ ನಿಮ್ಮ ಪ್ರೋಗ್ರಾಮು ಹಾರ್ಡ್ ಡಿಸ್ಕ್ ಅಲ್ಲಿ ಇದೆ ಅಂದ್ರೆ the CPU is not aware of the existence of hard disk. Okay, CPU is only aware of the existence of the main memory or the RAM. ಆದ್ದರಿಂದ ನಾವು ನಮ್ಮ ಪ್ರೋಗ್ರಾಮ್ಗಳನ್ನ ಎಕ್ಸಿಕ್ಯೂಟ್ ಮಾಡಬೇಕಾದ್ರೆ ನಾವೇನ್ ಮಾಡ್ತೀವಿ, ಹಾರ್ಡ್ ಡಿಸ್ಕ್ ಇಂದ ನಮ್ಮ ಪ್ರೋಗ್ರಾಮ್ ಅನ್ನು ನಾವು ಮೇನ್ ಮೆಮೊರಿಗೆ ತಗೊಂಡ್ ಬರ್ತೀವಿ. So the process of transferring of any program from hard disk to the main memory will be done so as to execute our program. And now I can call my program as the process. Hence again the definition says that any process is nothing but a executable form of a program using some set of resources. You need to understand the meaning of process. Why? Because this whole second module is based upon only the process concept. Okay, right. So when process is given to CPU, it will request for resources like memory, input and output device, CPU time, etc. So any process, if it is placed in the main memory, so then it can request for some resources like memory, input and output devices, CPU time, etc. And after allocation of resources, process is executed by the CPU. So here, based upon the requirement of the process, okay, so the process will be able to request some resources based upon the task what it is doing, and if the resources are free means OS can allocate those many resources. Okay. And upon receiving the resources offered by the operating system, any process can be going for the execution. Okay. And results are ready for further processing, or I can store the result in the memory. Okay. Like here I've given some set of steps of execution. Okay. So once we write a program in high level language or assembly level language, okay, so for example, like I'm writing a C program, and that is a high level language coding it is. So once I write the program in high level language, that will be given for a compiler. So what the compiler will do normally, compiler will be able to convert this high level language into machine language. So this machine language will be again given for the linker, where I'll be getting the .exe file. Okay, so this executable file, or a file in the form of .exe, okay, this can be recognized by the CPU, and the process, right, in the form of .exe file can be executed by the CPU. So this means that if I simply give my C program with extension .c, okay, this particular .c program will not be executed by the CPU. Hence what we'll do is, after we write down the program, I'll compile the program and I'll be linking the program, and I'll be getting .exe file, and this .exe file can be easily executed by the CPU. Hence we say that program is just some sequence of instructions or some set of instructions that will be given for the computer for execution. Similarly, any process is nothing but the executable form of a program. Okay. And also remember that all these programs will be stored initially in the hard disk, and those all programs stored in the hard disk will not be executed by the CPU. Hence, for me to execute my programs, I need to bring my programs from secondary storage or hard disk to the main memory or RAM. Then only the CPU can access the RAM, and based upon the priority of the process, the CPU can execute the process. Okay. Yeah. So for your easy understanding, like I have made a small comparison between the process and the program. So where this process is like it is the executing part of the program, like as we discussed. And regarding program, so this program is nothing but a set of instructions so as to perform the particular task or function. Hence, any program is nothing but a sequence of instructions or some set of instructions so as to perform a particular task. So whereas program is nothing but a executable form of the program. Similarly, second point regarding processes, it has shorter and limited lifespan. So the lifespan of a process is short and limited. Why it is so? Because any process like will be terminated or ended after the completion of the task. Okay, so once the task or function is over means that particular process will be ended or terminated. Whereas the program has got longer lifespan, as the program will be stored in the M stand for memory, and until it is not manually deleted. So until and unless like any program is been deleted from the memory, okay, the program will be there in the hard disk. Hence the lifespan of a program will be longer when compared to the process. And third point in process is resource management is high in case of a process. Okay, why? Because for any process to execute, the process will be in need of so many resources, okay, based upon the functionality what the process is doing. Okay, hence the requirement of resources will be very much high, right, in case of a process when compared to the program. Why? Because if the program is simply stored in the hard disk, means that will not need any CPU time. That program placed in the hard disk will not need any sort of resources. Okay, right. And fifth point in process is that the process is active entity. Okay, so why it is called as active entity? Because like it will be I mean, any process will be ready for the execution upon the receiving of resources. Hence the process is active entity. And while the program is passive entity. So why the program is passive entity? Because any program will not be in need of any resource. Okay, and if the program is stored in the hard disk means the program will not be able to have any sort of resources. Hence, the program is a passive entity. So this process holds resources like CPU, memory, disk, input device, output device, etc. So the program is stored on the disk, right, in some file and does not need any other resources. Okay, so for this reason, like we call it as this program as passive entity, and the process is a active entity. So for your better understanding, you can like analyze like these comparisons, and you can understand better way like the difference between the process and the program. Okay, right. So for your information, like of course it is not there for syllabus. So like only to have the better understanding of the conversion of any program into the process. Okay, like that's been explained here. Okay, so once you write down any sort of program, say for example, if I'm writing C program, okay, so the name of program is sample, and as it is C program, the extension will be .c. Okay, and this can be called as a source file. So once you write down the source file, right, like in C language, let's say that particular source file will be compiled like using compiler. Okay, so upon writing the source file, I'll be giving this source file to the compiler and it will be compiled, and output of this will be the object file. Okay, so this object file will be having the extension .obj. Okay, so this object file will be given for the linker, where in the linker I'll be adding the header files. So for example, so .studio.h or say include.h, like I mean uh, standard input output .h, or I can have conio.h, mat.h, etc. I will be adding so many header files. Okay, and output of this will be the a file in the form of .exe. So this is the executable file in terms of zeros and ones that can be understood by any processor. So here we have the program, and this particular program will be converted in terms of .exe file using the compilation and object file generation and and the linking operation, and then I'll be having the like a file in the .exe form. Means the file is now in terms of zeros and ones that can be better understood by the processor, and the CPU can execute this particular process. Okay, right? Like here is the steps involved in the conversion of any source file to a process. Means any program will be converted in terms of the process. Okay, hence we say that like the process is the executable form of the program. Okay, yeah. Are you there? Arpita AG,
Yes, sir.
are you listening, madam?
Yes, sir.
Yeah. Pratibha KL, are you there?
Yes, sir.
Yeah. Srinidhi IN.
Yes, sir.
Yeah. Like till now, like what we have discussed is yet, yet I have not started the actual content of your syllabus. So, but here only I am giving you the introduction to the process and program. Okay. Yeah. So next is, yeah. So several executions of the same program may be present in the operating system at the same time. So what do you mean by this is like a process is divided into many parts and given for execution. Say, suppose if I have a bigger process, huge process, large process. So then what we'll be doing is I'll be dividing a huge process, large process, a bigger process into so many parts, and I'll be giving or will be storing so those small parts of process in the memory. Okay, so what is the advantage of this particular process of dividing a huge process into smaller subparts and storing the memories? I can store different processes. Okay, so I can store so many processes inside the memory. Why? Because say the CPU will not be busy in executing only a single process. Okay, hence what I can do is I can go for execution of many processes. Okay, using concept of dividing a huge process into so many subparts. Hence I can accommodate so many n number of processes. Okay, so like we know that computer runs parallelly multiple processes. So whenever multiple programs are running, we need multiple process to be executed on the CPU. So using the division of a huge task, huge process into so many subparts and storing those in the memory, I can handle n number of process, and like in general, any operating system can execute multiple number of processes. Okay, any operating system nowadays will be able to handle multiple process simultaneously or parallelly or concurrently. Yeah, user cannot handle these multiple processes. Okay, so this becomes hard to any user to manually intervene and to take care of the execution of these multiple processes. Hence, what we have is we use the operating system which can take care of the execution of multiple processes parallelly or concurrently. So OS handles these processes and allocates resources whenever the process requests for resources. So for any process to execute, it must be in need of some resources. So once any process is requesting for a resource to operating system, so what operating system will do is operating system will consult the resource table, and based upon the availability of the resources, any operating system can assign the resources to the process, and the process uh, can be going for the execution stage. Okay, so once I say program means like we have basically two kinds of programs. So the one we call it as concurrent programs, and second one is sequential programs. So like regarding concurrent programs, the idea behind that is all the programs are independent to each other. Like as the name itself indicates, like the word concurrent means parallel execution or simultaneous execution. Hence, in case of concurrent programs, all the programs are independent to each other and run parallelly. None of the statement will wait for the previous statement to be over. Okay, right? So for this reason, we call it as parallel execution. Why? Because all the programs will be independent to each other, and none of the programs or instructions will be waiting for the previous statement or say previous program to be executed or to be over. So when compared to the sequential programs, as the name itself indicates, sequential means in a sequence, right, or in a queue, right? Hence, in case of sequential programming, we have the execution of instructions one after the other. Okay, so uh, that means that before you execute the second program, I need to have the completion of the first instruction or the first program. Okay, so until and unless I'm done with execution of first instruction or first program, I cannot go for the execution of second instruction or second program. That indicates a sequential program. Simple example is, so like, so for watching a movie, what we do is like we'll be standing like in a queue for a ticket, and like we're supposed to say purchase a ticket in a queue, means one after the other, right? So the kernel allocates resources to the process and schedules them for the use of CPU. So like here the main role of this kernel is to allocate the resources to all the processes which are requesting for the resources, and also to go for the scheduling. So this scheduling will be done by a part of OS that we call it as scheduler, whose main function is to allocate the process for the CPU to execute. So the kernel allocate the resources to the process. Okay, so based upon the request raised by the process, what kernel will do, that the kernel will be allocating the resources to the processes and also schedules them for the use of CPU, so that CPU can execute those processes based upon the priority, of course. So this scheduling is done by a part of OS that can be called a scheduler, where it will select a particular process for execution by the CPU. Okay, and this is done by the heart of operating system that is called as kernel. Okay, and the kernel will take care of all these aspects of allocation of resources and to go for the scheduling aspects. Okay, yeah. Again, we have the explanation of the first slide, where we dealt that the program is called as passive entity and process was called as active entity. Why? Because any program will be stored in the hard disk, and any program will not be in need of um, any resources as such. Why? Because it is not yet converted into a process. Okay, so whereas a process is called as active entity because all the resources are allocated to a process and not to a program. Okay, a very important point. The resources can be only allocated to a process, okay, initially while we begin the execution of the process, whereas the program will not need any sort of resources like either CPU time or input output devices, etc. Okay. So for this reason, like we call it as program is a passive entity, whereas process is a active entity. So the process actually performs a specified action in a program. Okay. So for example, like I want to have the controlling operation of a plant. Okay. So like to have a controlling operation of a plant. So what we do is like we'll be writing a code or a program. So just by writing a program, the program cannot do all the things by itself. Why? Because it needs to be converted into a process. And the way to convert any program to a process is, as we saw in the like this slide. Okay, so once you write down the source file, okay, so that source file, suppose if it is a high level language like C program, okay, so this source code needs to be compiled using compiler, like so as to have generation of object file, and this object file needs to be linked using a linker where I'll be adding the header files, and after that I'll be able to generate the executable form of the file. So this is the process involved in the conversion of any program into a process. Okay, so fine. So next, like next we have like a small program has been given here, like along with some diagram. So for this, the concept is a program and an abstract view of its execution, like how we can expect the like any process to be executed, and the abstract view of a program. So like in the book, like they given a simple program here. Okay, so this program is called as program P. So where a file is present somewhere in the hard disk, right? So this hard disk can be called as the secondary storage device or baking store device. Okay, so like in the hard disk, like we have stored a particular file here, right? And the file name is info. Okay, so a file name info is being stored somewhere in the hard disk, and CPU is not always busy with execution of only single program. Why? Because suppose if I'm executing only single program in the CPU, so then will not be able to utilize effectively 100% CPU utilization will not be there. Hence, what we can do is I'll be storing multiple number of programs or processes inside the memory. Okay, so the CPU is not allocated to only one process for a longer time. Instead, what we do is my CPU will be executing a small part of many processes, or the CPU time will be divided among n number of processes. Okay, so a small time quantum or a small CPU time slot will be allotted for each and every process. Thereby, I can handle n number of processes. Okay, so here we have a file, so by name info, and we have defined an integer, so by name item, and we have some commands used here, like say open. Okay, so this open is a command whose main function is to read this file, so by name info. So while not end of file, like I'll be reading the file info. Okay, and also I'm going for the printing option. Okay, like here I'll be in need of the input and output operation where I'm supposed to go for the printing operation. Okay, I repeat, like here we are like say just discussing a program and an abstract view of its execution. Where we have a program P and we are trying to initiate a file, and the file name is info, right? Here it is. So one integer is also defined, so by name item, here it is. So first we need to open the file, right? Why? Because for doing any sort of operation, I need to open the file first. Okay. Let's say let's say whether I'm doing say read operation or write operation. For doing any sort of operation, I need to first open the file. Okay. Like we'll be opening the file info, okay, using the read command, right? So hence only the file can be read and no writing facility is there. Why? Because if we're doing the read operation, hence I cannot go for the writing operation here, right? Like until the end of the file is reached, what we'll doing is like I'll be reading some items, okay, and those items are declared as of type integer, okay. Hence I'll be reading a letter, say A, B, C, D, like say some letters I'll be reading, and that letters is printed. Why? Because at the end here I have used the print option, okay. So whatever we read from the file, those contents will be printed, okay. So here the file is present somewhere in the hard disk, and the address space of the program will be consisting of, see here, address space of program P will be consisting of instructions, data area, and the stack of the program P. Okay, so this stack is nothing but a temporary memory location, right? That is, so this stack will be coming into picture. So like whenever we use something called as functions are called, okay, and here the functions are, say, so this open is a function and this read is also a function. So like in the program, whenever we use some functions or procedures, so then stack will be coming into picture. So this program is given to the CPU, okay, and the CPU, yeah. So because CPU is not always busy with the program P, why? Because I need to have the multiple number of programs that will be run on the CPU. So the CPU cannot be allocated to only single or like single program or single process for a longer time. So when the process starts running on the CPU, the OS will allocate the different resources based upon the request raised by the process. And here the request is for the printer. Why? Because in the program, as I have used the print operation, here the process may be requesting for the printer resource. Okay, so when a user initiates execution of the program, the OS creates a new process and assigns a unique ID to it. So here for each and every process, you have the identification of each and every process will be done by its unique identification number. Okay, that is, so what OS does is like it will create a new process once the user initiates the execution of a program, right? And the OS has to handle multiple number of programs or processes. Example, say, suppose if there are 4 processes running in a computer system, so then the execution of process 1 starts. So then OS will not be always busy in executing process 1 only. So the OS will be creating a new process that will handle only process P1. Okay, so then OS will release it. Okay, I mean OS will release itself for process P1 and will create one more process. Okay, that will take care of the second program. Okay, and so on, right? And like this, our OS will be able to handle multiple number of processes or programs. Okay, right. So this OS will be able to, what it is, yeah, OS will be able to allocate unique identification number to all the processes to know the termination of the process. So as to have the indication of the status of each and every process, OS will be able to allocate a unique identification number to the process. So once the process is select given for CPU for execution, so then OS will be able to allocate the resources to it. So like sufficient amount of memory should be allocated for a process and address space of the program and IO devices to interact with the user, etc. So upon the initiation of the execution of process, the OS will be able to allocate so whatever the resources that the process request, those requests will be allocated by the OS. So next concept is say different components of the process, and here we have so basically six number of components are there for a process, and those are like unique identification number and the code of the process and information or the data of the process and the stack. Like as I told, so this stack will be coming into picture whenever we use the function call or procedures in our program. And fifth component of process is the resources, and we have so many sorts of resource. Like I can have CPU as the main resource, or I can have memory, input and output devices, network throughput, electrical power, etc. And last component of process is CPU state, and this CPU state will be indicated using PSW. PSW stands for process status word. Okay, right? Processor status word and GPRs of CPU. Yes. So this word GPR stands for general purpose registers. So like in the next class, let me discuss all these different components of process, where basically we have a 6 number of components for any process. Those are identification number, code of the process, data or information of the process, stack, resources, and CPU state. Like in the next class, like we have the examples of a stack along with information regarding each and every component of the process. Okay, so for now, let me end this class. Okay, so you can simply log out and again log in for the next class tomorrow. Okay, fine. Thank you.